React India. React. React India. React.
Okay, so just as a heads up, just use the audio recording from the screen recording and not from the video, from this camera video here. Just as a heads up, because the screen recording video audio has uses a better microphone. Okay. Hi there, hi React India. Welcome to my workshop, Build Your Own V0, powered by server-driven UI and AI. If you haven't heard about server-driven UI, I'll explain what that is when we dive into the code, so don't worry about it. So my name is Ameer Saimi. I'm a staff software engineer at S&C Electric Company. Just so that way you know me a little bit better, I'll tell you about myself briefly. In my free time, I like to bake delicious baked goods. I like to program. It's not just a profession, it's a hobby of mine as well. I like to hike and explore nature, and I like to lift heavy circles. So if you want to talk to me about any of these things after the workshop, feel free to send me a message or send me an email or anything like that. So I mentioned I work at a company called S&C Electric Company, and S&C Electric Company is a global provider of equipment and services for electric power systems. We were founded in 1911 in Chicago, where we design and manufacture switching and protection products. Today, our diverse global workforce develops innovative solutions for a more intelligent and resilient electric grid. Building on this legacy of technological innovation and customer service, S&C empowers the transformation of the grid for an outage-free, sustainable electrical energy future. So let's dive right into what we're building today, which is a clone of V0, at least like a very bare bones clone of V0. And this is a video recording I made that walks you through, what you're doing. So there's an input field and a button at the bottom, and we prompted the AI to create a sign-up form. And it'll take a second because in this video that I'm showing you here, it's running on my laptop. And so here we can see it generated a sign-up form within a card that has, a couple fields and some text, or a button rather. I do know personally, since I worked on this, that it, for whatever reason, hallucinates and thinks that there's a component called text. So I'm just telling it that the text component doesn't exist. And once I clarified that for the AI, it generated the text for the form here. So create an account, name, email, and password. And now I'm prompting it to add a confirm password field below the password input field. So we'll see once, it takes a second to generate and run on my computer, that we get the card to display with a confirm password. And now I'm asking it to add some additional padding above the component, or the button rather. And a thing to note is that the preview here that we're seeing is the actual components being rendered. It's not a screenshot or anything like that. I don't show that in this video, but you could interact with the input fields in the button if you really wanted to. So once this loads, which takes a second, we'll see that it added some additional spacing above the button, the create account button. And so now I'm just opening some code that you can download by clicking that button, and I'm opening it in VS Code, so I'll bring it over in just a second. And here we can see the generated JSX that the AI generated for the card component that includes the sign up form that we just saw. So that's the V0 clone that we'll be building today, and it's using all of the SHAD CN UI components. So if you think these look familiar, that's why. And before we go any further, this is a free workshop and something I'm running on my own. So I have a GPU server running for the workshop attendees. It'll be running just for a few hours during the workshop while it's being streamed, since this is pre-recorded. But if you would like to help cover my GPU server expenses, you can go to my website, ameersaimi.com, and you can buy me a coffee, which is in the top right-hand corner of the page there. And if not, that's totally fine as well. Now, I've created a GitHub repo with the boilerplate code that we'll be using for the workshop today. So go ahead and scan this QR code and load up the GitHub repo, and I'll give everyone a second to whip out their phones and do that. The repo is on my GitHub profile, which is Ameer Saimi, just one word together, and it's the V0 workshop repo. So hopefully everyone has gone ahead and navigated to the GitHub page for the repo, and now let's talk about what we'll be building today. So I've broken it up into 3 sections, so it's a little easy to understand, and 3 steps. So the first step in building this V0 clone is to extract the metadata from all the components in our design system. In this case, it's shadcn. So we're going to write a custom prop parser that parses through all of the components that we have and extracts all of the titles, descriptions, as well as all the prop types for all of the components that we have. Then we'll jump into the AI portion and build this function to invoke our LLM. In our case, I'll walk you through what model we're using and how to connect to the server that I'm running for you guys if you want to run it through the server. And once we've created the AI model invocation and we've generated the server-driven UI for our interface, then we have to jump into the server-driven UI rendering portion. So how do we convert the server-driven UI schema into components that we can then render for the user in the web page, which is ultimately what we want to do. So let's dive right into the code. And this is the repo, in case you are wondering. So it's called Custom V0 Workshop, and it's at ameersaimi/custom-v0-workshop if you aren't able to navigate to it through the QR code. Now, there are 2 directories in here. There's a final and a starter. So if at any point you want to reference some of the final code, you can go ahead and do so by navigating to the final directory and finding the corresponding file. But we'll all be starting in the starter directory. So that's what I'll be walking you through there and how to build it out from there. So go ahead and clone this, and here's the web page running locally on my computer. But I have the starter directory open here, and let's just take a quick walkthrough through the repo to see what we have going on, the project structure, and then we'll dive into the prop parser. So at the very top, we have an AI directory, which is just a place for us to have the server function that invokes the AI model for us. Then we have the app directory. Since this is a Next.js project, this is just the boilerplate for a Next.js app router project. We have component docs. So I've gone ahead and done the work already of parsing, or rather not parsing, but retrieving all of the component documentation for shadcn UI components. And so I put all of their markdown files for their documentation in this component docs directory, which we'll use in just a few moments. There's a components directory, which has a subdirectory called UI rather, and this includes all of the shadcn UI components that we'll be leveraging to generate our interfaces. There's 2 other directories in here. There's a component factory and a generated code renderer and a V0 chat, but these are 3 components that we will be utilizing in just a few moments. Hooks is just boilerplate from the Next.js create React app or create app command that I ran. The same thing with lib and node modules, and same thing with public as well. Now I've gone ahead and pre-parsed all of the components and committed the parsed JSON file, which is what we'll be creating, and they're available here through the available components JSON and the component props JSON file. The rest of this is, boilerplate for a Next.js project using shadcn and Tailwind. The only other thing is there's a get components file and an index.js file, which I'll explain how to construct these and what they do. And then lastly, there's this prop parser as well. So now that we've gotten that out of the way, I've already added all the dependencies that we'll be using for this workshop in the package.json file of the project. So in the starter directory, just go ahead and run npm install in your terminal to install all of the dependencies. Now, I've already done that, so I'm not going to be running that command, but depending on your internet connection, it may be a little slow, maybe not. So I'll just wait here for a second for everyone to run that. It should be pretty quick, but if not, don't worry. Okay, so hopefully everyone has been able to successfully install all of their node modules, all their dependencies for this project. And I'm going to move forward with the prop parser. So the first step, like I mentioned, is extracting the metadata from all the components that we have available. In this case, it's ChadCN, but if you want to use this in your own design system, for example, or to leverage your own design system, you can replace the ChadCN components with your own design system components if you want. So here, let's go ahead and open the prop parser. I've done some very basic setup in this file, which we can see here. We're just importing the FS package, the gray matter package, which we'll be leveraging to read the front matter from some of the documentation files, and this React docgen TypeScript library, which if you haven't heard of, it's a really cool library, and it will be leveraging this to actually parse the props from each of the components, and it will return to us a JSON object, which we'll write to a file. So with these three dependencies imported, we need to do some configuration for this React docgen TypeScript file, or library rather. And so the first thing that we'll be doing is we'll be creating this options object, which we'll just be using to configure this React docgen TypeScript. And what we'll do is we'll do save prop value as string and set this to true. So that way it saves the prop values as a string as opposed to a nested object, for example. And once we've created this options object, the next thing we'll need to do is we'll need to parse through all of the component documentation files and retrieve, or rather compile, a list of all of the component file names. So that way we can then parse the appropriate or correct component file names. So what we'll do is we'll just do const component file names, and we'll set this equal to fs, and then we'll do read directory sync, and we'll be reading directly from this component docs directory. And just as a reminder, these are all of the markdown files for the documentation for ChadCN UI components. So here we have accordion, alert dialog, etc. And if we open these, specifically why we're parsing these files is because they have front matter, which is basically like metadata for markdown files, and we have the title, a description, and there's other information here as well, but we just specifically want title and description. So we'll retrieve all of the files that are within this component docs directory, and then we're just going to map over each of them. And what we're going to do is we need to extract the metadata from each of these files, and we'll be leveraging this gray matter dependency, this library here. And so what we can do is we will do matter, and we'll give it this read file sync, and we'll construct this template string here. We'll do component docs slash, and we'll just do file like so. And we'll just do two strings that returns to us the string contents of the file. And the matter library will then parse the front matter for us, and we can deconstruct an object, the object that's returned by invoking the matter library. And specifically, we'll just grab this data object here. So that retrieves the front matter for us, and then we can just return an object, and we'll put title, and we'll do data.title, and we'll do description, and we'll just do data.description, and we'll do file name file.split here, and we'll just split it on the dot for the extension, and just grab the file name like that. And that's all we need to do. So by doing this, we're extracting all the metadata from the documentation file, and we're compiling an array for each of the documentation files that represents each of the components that a developer or user can use. So once we've done that, we need to construct some other information as well. So as part of this prop parser, what we're doing is we're parsing all the props from all of the components that are available to us in our design system, or in this case, ShadCN, and we need to generate a couple of files. The first one is just a JSON file that has all the props, their types and their names in a giant JSON file that we'll be feeding to our AI to give it some context. The second one is we'll be generating a file that lists out all of the components that are available in a massive array as well, and then we'll be feeding that as context to our AI. And lastly is we'll be constructing an index.js file that basically has all the imports and exports for all of our components. So it's a single entry point for all of our components. And we'll be leveraging that to more easily construct our server-driven UI without having to write a whole lot of extra code. So now that I've explained that a little bit, let's continue writing this file. So we'll create two variables here, one being component imports, which is an array, and the second one just being component exports. And you'll understand why we're doing this in a moment, but basically these are being used to construct that index.js file that I was telling you about that has all the imports and exports for our components. Once we've done that, then we're going to go ahead and construct a map object for our component names, and we'll just do a new map like that, and we'll create another variable for the component prop, and that will just be a big object like that. Okay, so now let's parse through all of the components. So we'll go over each of the components that we have parsed to the documentation files, and on each of those, in this case, we're just going to extract the file name, but if you wanted to leverage the description or the title, you can, and that's why I wrote this code out here just to show everyone. But in this case, we're just going to be using file name because each component in ShadCN, they do a pretty good job of documenting their components using JSDoc, and so the React Docgen TypeScript will be able to parse the descriptions that they've defined for each component that way as well. But if your custom design system doesn't do that, don't worry. Just use the matter to extract the front matter data from your markdown files from your documentation, and you should be able to achieve the same result. So now that we've started iterating each of the component, let's first grab all of the props for the component that we're going over. So let's do const props is equal to docgen dot parse. So we're invoking this React Docgen TypeScript library, and we'll give it a template string. So we'll construct this path here. So it's components UI, and this is the directory that has all of our ShadCN components, and we'll give it the file name, and we'll just do .tsx because they're TypeScript files. And then we'll pass it options, which is this option object that we configured at the very top. And if there are no props, then we'll just return quickly. But if there are component props, then that means that it's a component that someone can use, that a user or developer can use. And so the first thing that we'll do is we'll go over the component imports, and we're going to add a new item to that array. And so we'll make this a template string, and we'll do import like so. Typo, sorry. There we go. So we'll do props.map. Okay, and this will give us actually all of the components that are within the file. So ShadCN exports multiple components from each file. So this props object from by invoking this React.Gen TypeScript library, will actually return to us each of the components and then their respective props as well. So we'll iterate over each of those components in this case, and what we'll do is we'll just add a component dot display name like so, and we'll join all of these with a comma and a space. So that constructs the import. Then just to finish this off, once we're done with that, we'll do from components UI and file name like so. Okay, so that constructs the import. What about the export? So the export, what we'll do is we'll do component exports push, and we'll spread all of the props dot, and then we'll map over each of the component, and we'll grab the component here, and we'll do component dot display name like so. So we'll use this later to construct the export definition at the bottom of this index file, which we'll see in just a few moments. We've constructed the import and the export. Now let's go over each of the components that's exported from each file. So we'll go over the props. We'll do props for each. We'll call the variable, the parameter to this arrow function component, because it's a component. And what we'll do is this component names map object that we created up top, we'll do component names, component names dot set, and we'll set the key in this map object to the display name, and the value of it will be an object. So we'll just do title component dot display name. The description will be the component dot description. And the last thing will be a file name, which will be component dot file path. So that is adding a new key, or a new object rather, new entry to the map object for each component. So all the components from each file, the individual components that are exported from each file, we're adding to this map object here. And once we've done that, then we'll create the prop. All those component props. And we'll set this to an object, and we'll do object.keys, and we'll go over each of the component props. And for each prop key, we'll go over. And what we'll do is we can deconstruct a couple of things from the component props prop key. So the first thing is default value, description, name, which is the prop name, type, which is the type for the prop, and then whether it's required or not. So this is all the data for each of the props, for each component that this React.Gen TypeScript library is extracting. And now we'll just add to this component props. We'll add the prop key, and we'll set it to, and we'll do default value, description, name, type, and required. So the reason why we're doing this step as opposed to just setting this component props object to what's returned from this React.Gen TypeScript library is that there's a whole lot of data in here, and something to keep in mind is that we're constructing this object that defines all of the props for each component, so that way we can feed it to an AI. But when we're working with AI, we have to be very mindful of context and not giving it too much information, otherwise it will get confused. Some AI models are better with that, some AI models are not. But in this case, the model that we're using, I've noticed through my development of this and testing and preparing for the workshop, is that we don't want to give it too much information. And there's a lot of information that this library will provide us that isn't really useful to the AI. All we really need is, the default value for the prop, the description of the prop if that's documented through JSDoc, the name, the type, so if it's a Boolean, a string, number, integer, etc., and whether it's required. That's all information that we really need to provide the AI. So we'll set that to this component props object, and once we've done all of that, we can go ahead and set this component props. Sorry, 1 second. Actually, there is a collision with this. That is my bad, actually. We'll call this component prop. Poorly named, my bad. We'll do component prop instead of component props because we already have another variable called component props. So we'll do component props, and we'll set it to component.displayName, and we'll set it equal to, and we'll pass it three things, props, the component name, like so, and we'll do component.displayName, and we'll do methods. So if there are any methods for this component, the library, the docgen library, will also parse out, whether there's any methods for that component as well. So we've constructed this component props object, and we've done all the parsing really. So now it's time to write all this information to 3 files. So let's go ahead and do that. The first thing that we'll do is we'll write to the available components JSON file. So the available components file, and here let me open this for you, is just a giant array that will then feed to the AI that lists out all the available components, the file name if that's useful to the AI, description if that's available through the JS docs. And so what we'll do is we'll do fs.write file sync, and we'll just call it available components.json, and we'll just do json.stringify, and we'll give it to array.from component names.values, and that's all we really need to do. We're just writing this JSON array to this file. And then let's write to this component props file. So it's a little large to open in VS Code because my VS Code will start to chug a little bit, but I created a formatted version of this file. It's called pretty component props, which is already committed to the project. So here we can see that this is what it looks like. So we have the key for the object is the component name, and then we can see the props is this massive object. So we have the different prop types and their default values, descriptions, if there is one. Some of them do have a description, the name of the prop, the type of the prop, and whether it's required or not. And I'll just close this before my VS Code starts to chug a little bit, but we'll do fs.write file sync, and we'll call this component props.json, json.stringify, component props, like so, and that will write to that component props file. And then lastly is we need to construct this index.js file. So like I mentioned a few moments ago, the index.js file just outlines all of the components that we can use and imports them into the file and then exports them. So it's a single entry point for us to then ingest at a later point when we're actually creating the server-driven UI. But this is just a preview. So again, I've already created this and committed this to the repo. So here you can see that we're just importing all of the components and then we're just re-exporting them from this single file. So it makes it easier to work with. In just a few moments, you'll see why. But this whole file is dynamically generated, and we'll generate it with just a few lines here. So we'll do fs.write file sync, and we'll do close index.js, and we'll create a template string here. So what we'll do is we'll do a component imports join, and we need to do a new line for every import, and then we'll do export like so, and inside we'll do component exports.join, and we'll do this. And that will then dynamically generate this index.js file like so. And that's pretty much it for this prop parser. So we're extracting all of the props for all the components. We're compiling a list of all the available components that will feed to our AI. We're compiling a list of all the props available for each individual component. And we're also generating this index.js file as well. So those are the three files. You don't have to run this because I've already pre-generated the appropriate files, the JSON file and the index.js file. But if you want to, you can go ahead and run this. I have created two simple commands in our package JSON file for the repo. So the first one is generate props, and the second one being prettyify component props. So generate props, we'll just go ahead and run the prop parser, but it will also run this prettyify component props, which will then create this formatted version of the JSON files, just so that way it's a little easier to read. But you don't have to run this. You don't have to generate the pretty JSON file. So that will go ahead and generate all the files for us. And we have completed basically one step, one of the three steps that we needed to construct this v0 clone. So now that we've done that, and I've shown you those three files, why did we create that index.js file? You're probably wondering, right? You can go ahead and import these components anywhere, but why are we constructing the single entry point? Well, when we're working with the server-driven UI, we don't really know what component we are utilizing. And so with that nature of it, we have to create a single entry point, so it's easier for us to dynamically decide what component to use without having to do dynamic imports, and that's just like really messy. It can be really messy from my own experience. So we dynamically create this index.js file, and then there is another file that I have created for you guys here, and it's called get, if I can find it. Yeah, right here. So it's called get components. So this is another file that I went ahead and created for us. And this just maps the component name to the import from that JS file. So here we're importing all the components from that index.js file. And I just created the simple function that gets the component based off of the component name here. So whether it's accordion item, accordion trigger, accordion content, etc., you get the idea. So this is this mapping, and it's a rather large file. So I just went ahead and created this on my own. There's no form items anymore. So I went ahead and created this on my own. But we could also dynamically create this, but for the sake of time, since we're already at about 30 minutes, we're not going to do that. But that's where that index.js file comes in, and then we'll be leveraging this get components in just a few moments. And if I'm going a little quick, sorry, but go ahead and you can reference the final repo, or the final directory rather, in the repo, and copy and paste just to catch up. So that's the get components. And again, like I mentioned, that's the first step of the three steps that we need to create this interface. So now let's do the exciting part and create the function to invoke our model. So there's some boilerplate in here already, just because it would take a lot of time to write. But I can explain some of the stuff. So at the very top, if you don't want to use the GPU server that I'm hosting, or rather, if you do want to use the GPU server that I am hosting, you can uncomment these lines here. And what this is just doing is we're using this AI package from Vercel, which is kind of funny because we're creating a v0 clone, and they created v0. We're using their AI director, or their AI library. And you can create this Olama object, which we'll use in a few moments. And we're just giving it the URL. So this is the URL for the GPU server. So it's just a subdomain off of my own personal domain, which is just v0workshop.ameersaimi.com. And that's the port that the Olama is running on that server. But if you have a MacBook, like a M-series MacBook, I highly encourage you just to run this locally, because I think it's really cool to run it locally as well. But if you don't want to, you can go ahead and use this as well. So below all this, we've created some Zod object schemas. And the reason why I've created these is because we need to have a way to tell the AI, what sort of structure it needs to adhere to for the output. So in this case, the AI library from Vercel leverages Zod, thankfully. So I created this complex types here, or complex Zod schemas here. So the first one is for props. So this is rather simple. It's just each prop can have a prop name and a prop value. And I just gave it a brief description, which is then also fed to the AI. We have a component schema. So each component has a component name, children components. So, children that are components that are children of that component, and then props. So this is leveraging this prop schema here. And then we have this components array schema. And this kind of mashes, allows us to create this nested object where components can have children components, which can also be a type of a component. And so here we have the super refine, and I won't explain all these steps because this is a little complex, but that's essentially what this is doing. And we're just enforcing that each component needs to have children components, whether it's none or some, and that it's this type of this component schema. So I created this type of component just so we can leverage this when we're writing some additional code in a few moments. And then lastly, we have the schema, which is just this components array schema. So this is just to rename it, but if you don't want to rename it, you can just leave it as components array schema. So that's all the setup for Zod. And again, if you want to use the workshop GPU server that I'm running, just uncomment this section, and you can import Olama from this, not this library, this import, but I'll show you in just a moment where to import it from. So let's go ahead and write some of our imports actually. So let's go ahead and import from the Olama AI provider v2. So this is something that we can leverage or utilize with this AI library from Vercel to utilize Olama, which is what I'm using to run the AI model in my GPU server. So if you aren't familiar, Olama is a really helpful tool that allows you to run AIs, or LLMs rather, on your machine, or in this case on a server. And so from this, we can import Olama, or if you're using the GPU server that I have, you can just import create Olama from this library, from this dependency here. We'll just stick with Olama for my case, but again, you can uncomment this and use the GPU server that I have running. Now that we've imported Olama, there's a couple things we want to import from this AI library. So the first one is generate text, which we'll use to actually invoke the AI and generate some text for us. Then we have output, and we have tool. And so it'll become apparent why we are importing all these in just a few moments. And then lastly, for the library imports is React element to JSX string from React element to JSX string. So this React element to JSX string library is what we'll be leveraging to create the text for the components that we then allow the user to download from the UI. So that way you can kind of see how the JSX is structured, and how we're doing that conversion from server-driven UI to JSX, because that's more easily understandable or readable to us as humans. And in terms of the but the local imports, we have three things that we need to import. So the first one is available components from, and then this is from the available components JSON file. This is the file that we generated with the prop parser. Then we'll import component props from a component props.json. And again, this is another file that we generated with our prop parser. And then lastly, we have our component factory. So the component factory is something that we'll be using to generate the actual JSX components, or do the conversion from the server-driven UI schema into a component that we can then render or display to the user. So we'll dive into that in a later point in the workshop, but for the sake of right now, just think that this works, right? So we've done all the imports, we've created our schema. So how do we actually get started with invoking the model? Well, luckily it's kind of easy. So we'll create a new variable, we'll destructure an object, which we'll add some things to in a moment, and we'll await generate text. And so generate text is that function that we're importing from the AI library. And this will give us two things rather, response and experimental output. So this experimental output is for a structured output response. And so it's just experimental from their library, but it's been fairly stable in my usage, and that's what we'll be leveraging for today. Now it accepts an object as a parameter. And so the first thing is a model. So the model is, and you can read their docs for this library, but we're just telling it what model to use. And so I'm just going to say Olama, and I'm going to specifically say the LLM that we're using for this workshop is Qwen 3 coder. So like so. And experimental output is output object schema. Okay, and I know it's still yelling at us, so we'll get to it in a moment. But next thing is tool. Well, actually, we'll do messages first, since these type errors are a little annoying. Okay, so we'll get back to messages in a moment. So the next thing we want to configure is the tools. So just as a recap, we've configured the model that we want to use for the invocation here. So we're saying use this Qwen 3 coder LLM. We're saying this experimental output and just giving it the schema, the Zod schema that we created, or had already created for us. And now we need to define some tools for the AI to use. So remember in the prop parser that we created a few moments ago, we're compiling an array of all the available component names. And we've also constructed this ginormous JSON object that includes all the information for all the props for each component. Now, it's not really feasible to just feed all of that prop information to the AI, because that would fill up a lot of the context window, and it would probably lead to a lot of hallucination and confusion for the LLM. So instead, what we're going to do is we're going to provide it a tool that allows it to retrieve the props for a component when it wants to. So we're giving it this tool, and then it will invoke it to get the props, the prop types, and descriptions, so that we can properly configure each component. So we configure this tools attribute on this object, and in the tools, we'll give the key in this object the name of the tool. So in this case, we'll just do component props. Excuse me. And we'll call tool, which is a function we imported earlier, and accepts an object as a parameter. And so the first thing is description, and I'm actually just going to copy this from my notes, and I'll walk you through it. So first thing is description. So we'll just provide a description, which will then be fed to the AI so it knows why it should invoke this tool. So in this case, we're saying it must be used to retrieve all available props for a component. Seems pretty straightforward. The input schema for this tool is straightforward. It's just a component name. So we're defining a Zod here. We're just saying it's component name of the component to retrieve props for. And then the execute is the function that will actually be called or executed when the AI wants to invoke this tool. So here I just have a console log, but you can remove that if you want. And what we do is we just get that component props object, which we imported from that JSON file we constructed, that we generated. And we're just getting the component name. So if that component name key exists on the component props object, then we just return the value for that key in that object, which is the giant object that includes all the props for that component. And if there are no props, if that component just doesn't exist, because the AI could hallucinate, we just say that there are no props available for a component with that name, just so that way it knows. So that's the tool. We just need one tool for this, which is great. Then we have the messages. So the messages is a giant array of all the messages, basically the conversation context, if you will, that we're providing to the AI, to the LLM. And we need to give it a starting point, a starting message, so that way we can, prompt it. So we're just saying, we define a system message that kind of tells the AI what it is And in this system message, we'll tell it what it has available to it. So let's go ahead and create this. So this is an array of objects, and there's a role, and we'll say that this is from the system, so not from a user and not from the AI. And there's content, which will set to a template string, and that's all there is to it. But this is where we do a lot of the configuration. This is where you can fine tune the results for your AI, right? It's this whole prompt engineering, that term that we've probably all heard of. And so this prompt is kind of simple, and I'll go ahead and copy it, and then I'll from my notes, and I'll walk everyone through, just because it's a lot of text to write. So I encourage you to reference the final directory that's in the repo to copy the contents for the message here. But basically what we're doing is we're telling the AI that it's a helpful agent that creates a JSON schema to construct a user interface. And the schema should match the following format. So although we do have the Zod schema definition up top, we also just need to tell the AI here what we expect as an output. So we say that we expect an array of components, and each object in that array has a component name, children components, which we were just saying as an array, and then props, and each prop is a prop name and a prop value, a string. So I found this structure to work pretty well. Then below that, we say to retrieve all the available component props, you must call the provided tool. Since we're only giving it one tool, it should know. You are not allowed to come up with your own prop names for any component. That's something I encountered when I was doing my testing. And each component will have a 12-column grid within it to position its children components. Then we say we must generate a schema for the interface, and here's a list of the components that are available to you. So we get all the available components, which is that array that we constructed as part of our metadata step, and we just say here's the component name, we get the component title, and then here's the component description if there is a description, and we just add those. So add all those. There shouldn't be hundreds of components, so this doesn't add that much to the context, but it tells the AI what it has available to it. And then lastly, since this is ShadCN, we just say, hey, you may use any Tailwind CSS utility classes on each component through the class name prop to add styles. So that way it can, add padding, margin, and position things if the user instructs it to through their own prompt. A quick note here, I had tested this out by creating a JSON file that lists out all of the, not all of, but most of the Tailwind utility classes. But by adding that to the context, that giant object, I started to see a lot of hallucinations. So I took a step back and I changed the prompt, the system prompt, to just say this instead. Now, we are accepting messages as a parameter to this function. And basically why we're doing that is because when the AI sends a response and the user wants to refine, whatever the AI responds with, we just invoke this function again, and we are just spreading the messages. So the client is then sending all the messages back. So there's no state management here, which simplifies a lot of our code, thankfully. So that's all we need to do to invoke the AI. Seems pretty cool, right? Just a few lines, less than 100 lines to invoke the AI and get some sort of output. Then what we'll do is we'll just get all the components. So component factory, hold on, this is supposed to be this. So we'll do component factory, which is that component that we created that we imported up top. So we'll get to what this looks like in a few moments, but basically this does the conversion from the JSON schema that the AI is returning to us and converts it back into JSX components that we can then render for the user. So we call component factory, and we pass it components, and we just give it the experimental output, like so. Now you're probably wondering, hey, Ameer, we're doing this in a server function. What's really cool in server functions is that you can kind of pre-render components in them and then return the data from the server function. And that's what we're doing here. I gave a talk about this more in depth, and there's a blog post on my website if you want to learn more about it. But that's all we're doing with these few lines here. Now we're just going to add a console log just so that way it's a little easier for us to debug, but we can see what the AI is outputting. And then lastly, we're going to return the result from the AI. So what we'll do is we'll do a component text string, and we'll call that React element to JSX string, and we'll pass it the comps, which is the rendered JSX for us. Then we'll do components, which will do a component factory and self-closing, and we'll pass the components and experimental output like so. The reason why we do this twice is because, just for the sake of verbosity, if you will. So you could replace this with components, but which we can do here, like so, and it does the same thing. And then lastly is we return all the messages. So just so that way the client has the full context, the history of the chat, we just return the messages, and we do response.messages. So response.messages is coming from the response by invoking the AI through this generate text. So these are any new messages from the AI, just so that way it has it as part of the context if the user wants to refine the output. So that's the second step out of the 3 steps. So we parsed all the metadata from all of our components. We've now written the code to invoke the AI. And the last step is to render the server-driven UI. So there's 2 things that we need to look at. First is the component factory, and then the second being how do we build that interface, that chat interface. So the component factory, I've been referencing all along, and this is already created for us since we're a little short on time, but so we're not rewriting this as part of the workshop. But basically what we're doing is we're importing this component type from the model file actually. And for each component that's in that JSON object, so that schema, just as a reference, as a refresher, right? It's an object, it's an array of this object, of each object is representative of a component, and each of those objects has a component name, children components, which are children, which also follow the same format, and then an array of props, which each item in that array is an object that has a prop name and a prop value, like we're seeing up here. So the component factory just parses through and converts this format of objects into JSX components and nests them properly. So there's a lot going on here. So we get our components and we iterate over them, and we call this generate child. So generate child renders the actual component, and so we go over the component. If there is no component name, then we just return a fragment like so. And then here we invoke this get component function. So if you remember back 30 minutes or so, this get component file maps the component name as a string to the import from the index.js file. So here we're just passing in the component name, and we're just calling a found component as a variable. And if there is no component that's found, that either means the AI is making up its own component name, or it's a HTML semantic component, so like a form tag or an A tag, which is totally fine. So, but to add support for those browser built-in components, if you will, excuse me, I need a sip of water. So to do that mapping, what we do is we grab the component name, and if it's a lowercase, that means that it's a non-React JSX component. And we call this dynamic component function, which is defined all the way up here. So we just call React create element, and we give it the component type, which is, in this case is the component name, so A or form or something like that. and then any of the props, which are the attributes that can be configured on that as well as the children. So we just spread this giant object here. And this will create for us that found component, which is the built-in a or form tag or whatever. And if it doesn't start with a lowercase letter, that means that it's a JSX component that it's trying to make up. And so we just render a fragment just so we don't break everything. And once we've done that, then we get all the props and we get all the children. And for each of the props, we just create an object, because you can spread objects for props, but not arrays in React. And so we get all those and we add it to this giant object, this record here. And we're just adding the prop name and the prop value. So prop name, prop value, if you remember, again, is the structure that we're telling the AI to give us the props, so prop name and prop value. And if there are children, then we add the children to this children's array. And if there are children components, which are not children, so children can be like just plain text, for example, the children components are other React components, JSX components, for example, then we add them to this children's array as well. But we call this generate child function over again recursively if it is a JSX component. So that's how we build that tree. And then lastly, if there are children, then we render the found component. We pass the props, we spread the props object. We're just adding a random ID as a key. I know this isn't best practice, but just for the sake of time, we're just doing this. And then we're passing the children. And if there are no children, then we just render the found component like so, and we don't give it children. The reason why we do this is because you'll retrieve or encounter a lot of errors if you pass children like this to a component that doesn't support children, like an input, for example. So it's just nicer just to do it this way, but you could totally do it without that. And that's all the component factory does. So it just does that mapping, that conversion of that object. And then we just return the component factory like so. So that's the component factory. And lastly is, how do we construct that chat interface? So just as a refresher, this is that chat interface, right? You have an input, you have a button, and this will then display the text that you type and then the output from the AI. So let's take a look at the V0 chat. And again, I've done some setup in here, but not much. For the sake of time, I've gone ahead and already created the CSS and all the styles that we'll be leveraging. So we can just focus on the logic and the rendering logic for this component. And this V0 chat is used in the page. So in this app, page.tsx, just if you're wondering. And we're passing the model, the server function, as a prop to this V0 chat, just so we can call our server function without having to build an API explicitly. We can just pass it, and then through the magic of server functions, API endpoints created for us. So there's two interfaces specifically defined here. One is for the props, which is just this handle model. We're just importing a model for the types, and then chat history. So we have this chat history object, which we'll see us construct, or you'll see us construct in just a few moments, but this just maintains the chat history so we can render the chat and the history respectively. So the type, there's two types, the user and response. The response will be the rendered components, and then the user will be the text that you're prompting the AI with. The text content, if it's a user response in the chat, the component content, so the rendered JSX elements, and the component text string. So since we're doing that conversion in the server function, we're just passing that string that represents the JSX, and we're storing that here as well. I mean, you could store this in local storage or something, but we're not building an enterprise application in this workshop, so we're just doing it this hacky way, if you will. So now let's go into the component itself. Again, it's pretty simple. We're returning, at the end of the day, we're just returning some JSX. But before we do that, actually, let's go ahead and import all the things that we need. So first, we're going to import some things from React. Specifically, what we'll want is we'll want to import the type of JSX. We'll want to import the type of JSX. We'll want to import useEffect. use ref, and use state. So pretty simple hooks from React that we've all have probably used. Then we want to import the type of model message from the AI library. We already have the import for the model here. We have our CSS imported as well. And now we just need to import some components that we'll be using. So we want to import the input. So we'll just be using the shadcn component that we already have available to us. And we'll also import the button. Button from button. There we go. We'll also import spinner from spinner like so, just so we have a loading state. And we have an error boundary component that I created as well. It's just called generated code renderer. Code renderer from generated code renderer, like so. Okay, so those are all the imports that we need. We have the types defined, so now let's actually dive into creating the component and setting it up. So let's set up our state. So we'll set up a couple of things here. We'll do our prompt, which is the prompt that the user is typing into the text input. Setter, use state. We have a chat history. Chat history setter. State. And this is an array of chat history, which is that type we defined above, and we'll set this to an empty array. We have messages, so we have that message context, that message history, so we can pass it back if the user wants to invoke the AI again. And we'll do messages setter, use state. This is the type of array of model message, which is that type we imported at the very top. And then the last one, not import, we have a loading. So it is loading setter. Use state, and this will just be false. So this will just be inferred as a Boolean type. Now we have two refs that we want to create. So we have an input ref, use ref, and the type for this will be an HTML input element, and we'll create the same one for a chat ref, which will just be a HTML div element. So the reason why we have the refs, the first one, the input ref, is that way we can clear the input once the user has clicked the submit button, and we have a chat ref so we can scroll the chat div, the history div, as the user enters text, and then the response is returned from the AI. So now to write the code for the scrolling, the auto scrolling. So we'll have a use effect, and let's pass an arrow function. The dependency array for this use effect is nothing, just because we're setting up an observer to do the scrolling. And so we check if there is a chat history or a chat ref dot current, and what we do is we configure a callback to be invoked when when there's new content, and we'll call it a mutation list, mutation record, which is an array, and we have an observer. We actually don't need that. So inside of here we do a for let mutation of mutations mutation list, and if the mutation dot type is equal to child list, and there's a chat ref dot current, then we do a chat ref dot current dot scroll to 0 chat ref dot current dot scroll height like so. So this will scroll the chat history div element to the bottom once there's a new message or new content added. So that's what this callback function does. But how do we actually pass it? We need to pass it to an observer. So we do observer is equal to a new notation observer, which is a browser API, and we just pass it the callback function, and we do observer.observe, and then we just do chatref.current, and we pass here, we just do child list true, so that way it is watching the children of the chatref element. And we can do some cleanup. We can do observer.disconnect if the component is unmounted for some reason. So that handles the scrolling. But now how do we want to actually get into the nitty-gritty of actually invoking the AI. So we'll have handle submit, which will be an async function. And inside of here, if there is no prompt, length, which is that stateful variable that has the text content. If there is no prompt text inputted, we just return quickly, so that way we don't have to actually invoke the AI. And if we have an input ref.current, then we just do input ref.current.value. And we set it equal to an empty string, just so that we clear the input now that the user has clicked the submit. And we set the isLoading setter to true, and chat history setter, and we get the previous value, and we spread the previous, and we add a new, so we do user, text content is the prompt, and this is then going to send that new prompt from the user to the AI. Well, at least we're setting it here as a part of the history. To actually invoke the AI, we do a response, and we do await handle model, which is the server function that we're passing to this client component. And this accepts an array. So we pass it, we spread all the messages that we currently have, just because in this case, we don't know if this is the first time the user is prompting the AI or not. So we just give it all the messages. So it has the full chat context. And then we do, just like we did above, we do type user, and we do, or sorry, not type, role, and we do content prompt, like so. And this will invoke the server function, which in turn invokes our AI, and then we just have to handle the response from that. So luckily we're doing all of the server rendering for the components and that parsing on the server. So the response here in the client component is rather simple. We just check if there is a response.components. Components. So if there is, that means we did get some components back. And we just do a chat history setter. And this is an array. So we just spread the previous, and we add a new item to the chat history state that we're maintaining. And so it's a type of response. We have component content is the response.components. And we have the component text string, which is the response.component text string, like so. So then we'll take this stateful variable, stateful array, and we'll construct that interface in just a moment. And then we just do a message setter here. So we add the full chat context from the AI, and we just do previous, and we just do response dot messages. Okay. So the reason why we're doing this outside of this if statement, this if block here, is just in case the AI doesn't return components or encounters an error or something, it will still give us an error response message or a message, and so we're just appending it here as part of this message setter. And then we do isLoading setter to false. So this will invoke the function. We're running a little short on time, I think, so I'll just copy and paste this here to handle the download. So like we saw in the video at the very beginning, there's a button that a user can click to download the converted server-driven UI into a JSX string that we can then download into a file. And so that's what this function here does. It just generates a JSX file, a file with JSX file extension. We pass the generated text code, which is coming from this component text string here. And we're just triggering a download like that. But I'm sure everyone wants to get into the rendering logic here, which is, this is the last step, and then we'll be ready to run this and we'll see. So here, let's construct our interface. Let's first add a div inside of this style container div, and we'll add a ref, and this will be the chat ref, and we'll add a class name, and we're using CSS modules here, so we'll just use styles.chat container, like so. Now inside of this, we'll go over the chat history, and we'll map over each message, and what we'll do is we'll construct a switch, and we'll do message.type since it's a little nicer. So we'll have a user, and we'll return a div, and inside of this div we'll put the message.text content. So this is the text that the user is inputting, and the class name for this we set to styles.user input message. And if it's a response from the server, we'll do a return here. And this is a little bit more involved, but we'll do a class name of styles.generated UI container, like so. We'll add a button, which does the download for us. And we'll add a class name of styles.download, like so. Role is just a button, and the on click will be an arrow function, inline arrow function, and we'll call the handle download generated code, and we'll pass it the message.component text string. TypeScript will complain, so we'll just pass it. We'll nullish coalesce that, and we'll pass an empty string. And I'm gonna pass an SVG that I have here. So go ahead and grab this from the final directory if you want. But this is just a little icon I created for this. And then after the button, we call this generated code renderer, which is just the error boundary component that I created. And as a child of this, we'll pass message.component content, which is the server rendered components that we will then render to the user. So this handles the chat history, and if there, whatever reason, some chat history message was added that doesn't match any of the switch cases, we'll just return a fragment like so. Okay, so this is a typo. I put square brackets as opposed to parentheses. There we go. Okay, so that handles the rendering of the chat history. Now we want to render the input area. So we'll just do another div. On this we'll have a class name of styles.input container, and we'll add an input, which we already imported at the very top, and we'll add a ref of input ref. We'll add a type of text. We'll add a placeholder of whatever we want. In this case, we could just put like create a sign up with an email and password input. And on change, we get the event. We just call the prompt setter to e.target.value. And lastly, let's add a button. And on this button, class name, styles.submit button, disabled. So if it is voting, we'll just disable the button, and on click, and a submit, which is that function we created already at the very top. So we'll conditionally render a spinner if it is loading. So we'll just do a spinner like so, which we already imported, and we'll add a paragraph tag with submit. The reason why we have a paragraph tag is just so it's easier to change the styles of this, target it in our CSS if there is a spinner, if there is a sibling that is the spinner here. And that's pretty much it. That's our last step of creating the server-driven UI interface. So let's actually run this now and let's see if it works. So let's go ahead and the dev command. I have my terminal in another window, another screen, but I do have it running. So here we'll see that it renders here. So it's a blank screen with an input field and a button at the very bottom. But let's prompt the AI. So in my case, I'm using my local version of the Quencoder LLM model, but if you want to connect to the GPU server, go ahead and do so. So we'll just say create a signup form. Click on submit, and we wait a second. For me, it's a little slower because I'm running it locally, but if you're using the GPU server, it should be a little faster, hopefully. And what's happening under the hood is that we're making a call to the LLM, and we're giving it all that context of all available components. It's making the tool calls, and it should return to us in just a few moments. Sometimes it's a little slow. There we go. So it generated this interface for us. If we inspect our element real quick, I took out the console log statement. Okay, I'll add that back in just a moment, just so we can see what's going on. But these are elements that are being rendered, right? So here we can see the elements that are being rendered. And like I mentioned at the very beginning, for whatever reason, the AI does think that there's a component called text component. So we just say text component is not an available component. And it should fix this. And so then we should see the labels for the inputs and then the text actually display within the button element here. So give it a second. It's going to take a second to load because I'm running this locally, which is pretty cool. I'm running it locally. Sometimes it works, sometimes it doesn't, but that's just how it goes with working with AI. I'm a little curious of what's going on. So we can click on this download icon here and it'll download that JSX file for us. We open it in VS Code, and here we can see what's rendering. So we can see that there's a card component that is rendering with some classes here from Tailwind. We have a React fragment. We have, let's see, there's an input field. There's a button, but the button, for whatever reason, doesn't have anything passed to it. I don't know why. So let's go back and let's say add some text to the button. So this just goes to show like what it's like to work with AI. We can build all these in schema enforcements under the hood, but sometimes it just doesn't work, and that's okay. So fingers crossed. Take a sip of water real quick. Okay. I don't know what it thinks it's doing. Let's see. If we inspect element, we can see that it's not even passing any content to the button. So, let's see. Add text to the button that says sign up. And let's see. So takes a second, and here in my terminal, just while this is loading, here we can see that I am console logging some stuff. Here we can see the component name, card, and the children components, and the props, which are objects that the AI is outputting for us. So it is adhering to that structure that we defined. Curious if they will show up. They don't show up here. Okay. That's fine. Let's just go ahead and refresh this and try again. So let's try one more time. Again, this is unfortunately just how it is working with AI. You never get the same results, never consistent results. Sometimes I've seen it where it creates the card and then the content, the elements and buttons, but it adds it like outside of the card for whatever reason. Sometimes it adds it inside of it, but you can just work with it. Okay, it's doing the same thing for some reason. So let's just go ahead and create a login form inside of the card. Let's be a little bit more verbose, a little bit more clear. Maybe the AI will pick up on this. There we go. Okay. So again, like we saw, right? It's not very consistent. So some cases it will do a good job, some cases it won't. So in this case, it created the card, added a label, a title to the card, added the button with the text content here, and then the input. So here we can see that we can interact with this, right? This is being rendered live. We can click on this download and we can see what it's actually rendering. So a card header, card title component, a found component is probably just a div in this case with the class name configured on it. This is just a label, I'm sure, for no display name. And then the input, another input, and then the button here, which is in this card footer component. So we get a good idea of what sort of structure the AI is coming up with here just by downloading that JSX file. And then you can go ahead and copy this and paste this into your code base, right? If you're using this, or if a non-technical person is using this tool, they can go ahead and download this and send it to you and maybe take a screenshot as well. But in theory, if you're using the same components, you should be able to render the same UI. We can refine this interface a little bit with the AI by chatting with it as well. So we can say, like, add some padding between the email input and the password input. We can spell. Let's chat with it. Let's see. It should come back to us, and it should add some padding through some Tailwind classes between the two. Sometimes it works, sometimes it doesn't. That's okay. If it didn't, add spacing between the two inputs. Try again. And I've read some interesting articles that suggest not being nice to the AI, not saying like please or thank you, and you'll get better results for some reason. I don't understand why. But here we can see, so sometimes it's not consistent, sometimes it is. Let's say change the button text to sign up. Let's see. That should hopefully change it. Now, I know sign up doesn't make sense in this context, but let's see what the AI comes back with. There we go. So here we can see that for simple stuff like this, the AI does a pretty good job of changing the text content, for example, and then we could download the generated JSX. But the last thing is, before we end the workshop, is I want to show what this response from the server looks like. So let's go ahead and let's go back to the v0 chat component, and let's just console log the response from the AI. So here, response.components. Actually, hold on. Go to the model here. So we have experimental output, and so basically the structure for this looks like this. So it's this component name, children components, and props. And the props is that array of objects where each object has a prop name and a prop value. And then children components are just follow the same structure of component name, children components, and props. So server-driven UI is basically this, defining an interface through a schema like this, and then generating that, or rather parsing through that, and then generating the UI dynamically or on the fly based off of the response from a JSON API, for example. It doesn't have to be JSON, but in this case it is. So I think that's pretty cool, right? We did have some difficulty getting it to refine some things. Of course, live demos always go, poorly, but in my experience practicing and going through this and building this, we were able to achieve a pretty good result with just about an hour and a half time of effort building this. So we parsed all of the component documentation, all the metadata from all the components that we have available. We gave all that as context to the AI, as well as gave the AI a tool to invoke to get the props for each component. And then we built this chat interface all within an hour, which is pretty cool. There's some rough edges here. There's some work to do. We can refine the prompt. We can add some more detailed information to the props as well. But I think this is a great first step in building a V0 clone. And I really hope everyone got a lot of value from this workshop. So just want to say thank you so much. Thank you for attending the workshop. And if you have any questions or just want to stay in touch, you can add me on LinkedIn at this LinkedIn URL here. Visit my personal site, ameersaimi.com, to visit my site, look at any other talks I've given in the past, look at my blog posts. And if you have any questions, feel free to shoot me an email at this email, ameersaimi01@gmail.com, and I will try to get back to you as quickly as I can. All right, thank you so much. Oh, and last thing is, I was told to say this, is Tio Bore Koro. If you are going and speak Konkani, there you go. Otherwise, goodbye to the rest of you.
React India. React.